packet. Here it is. This page, I think it says example 10 in yours, maybe?
Yep.
Okay, so let's first draw the picture, x plus 1 and x squared minus 1. We get this region, and so we'll go pink and blue, because that'd be the coolest colors. So we'll draw them, and maybe we'll do some red. Here's x plus 1, bingo. And then here's x squared minus 1, looks like this. And fill it in, a little shady shade. Let's go pink. There we are. Beautiful, right? Let's go a little bit of blue right there. We're got it. This is different. So when I say volumes and I say we're going to do cross sections that are perpendicular to the x-axis of varying shapes. If you look around the room, can you guys see on the wall some of these fantastical pictures that we've made? Like this dude right here, made out of pentagons. This is what I'm going to do, is stack a uniform shape that fits within that area on there over top of a curve. And it creates these nice curvy looking things with geometric shapes. We have that little thing, we did a dinosaur. These are half circles laid across a graph. Here's a dumbbell, right here. And then there's this weight thing, too, that's on top of there. It looks like something to lift weights with. So that's what you can make out of it. What I did with this project and what you're going to do with this project is these slices, don't ask like, when am I ever going to use this? It's more like, look what I can make with this. And then later on you can say, well, maybe I can, this is what I can do for you. You can show it to somebody else and they'll, oh, that would be perfect for my new invention. I needed something for my robot. Which, by the way, is what Kieran used to say for everything. He used to take all our trash, anything that I like had in the house left over. He's like, I need that for my robot. This robot that never happened. And so one of these days we got to get him in robotics because he's got a lot of stuff that could make a robot. So I'm putting a cross-sectional slice that's a square on top of here. And what that means is it comes off the page. Are you seeing this? Look at this. This is a square off the page. I mean, look at that. Is that an amazing three-dimensional drawing capability? There's it's a square I laid across there. And then if I laid one next to it in a slightly different color so that you can at least parse the two out, and I brought it up to this speed, it's going to be a little bit taller because it's at a section where the gap across is a little bit taller. Okay, and then I will lay another one next to that. Let's do it in lime green. It'll be a little taller yet because the way these are constructed is that the heights, because it's a square, is the same as the width it is spanning when I lay it across that area. So as you lay those cross-sectional slices across there, can you picture if I do an infinite, hey, do you remember how wide they are by the chance? Like right here, if I just said, hey, what's the width of that slice? How wide do you think it is? Good to guess. I mean, just think what we've been doing a lot of lately. How wide is everything? dx, of course it is. That means it's infinitely thin. So if I laid those on there, what you're going to get is this super cool shape. Now let's do the profile. So go over here, let's do profile. The profile. So you look at it from the side. This thing is going to rise up and fall kind of like our curve on the side if you're looking in from that direction. Because it's going to have slices. But what's cool about the sides is they're perfectly vertical. So on that outer edge, as I look across the top, it's smooth along that outer edge. So right here, nice smooth wall, a flush wall on the outside. But if you look in from the side here, you see this arc on the side. And you think, what on earth would I ever use this for? Maybe it's like arch support for a new shoe that helps you survive in the sands of the United States after tremendous climate change. I don't know. You can decide. So I don't know if that bothers you. Climate change is like a nasty word, I've heard. So there you go. There's your thing. I have cross-sectional slices. They make interesting things. Think of 3D printing. This is the idea of layer by layer creating some kind of shape and a volume that we'd need. This is how much resin would I need to create this particular shape from a 3D printer. So I looked online, by the way, and there is a, I was trying to find like people using 3D printers in calculus, and there are. Like, so they're doing some volumes, creating them, and then they're printing them off, knowing exactly how much resin is being used because they're using the calculus that creates the volume to make it happen. Isn't that neat? I thought that was fun. Here's how it works. Do you realize that integrals are simply adding up an infinite number of these things? So if I could simply come up with a calculation for the volume of one of these things, which happens to be a square that I've laid across, okay, so I'm taking this blue one right here. Do you see it? If I could just come up with its volume, this is how you integrate it. It's simply the integral of the face of that thing, its area of the face, we'll call it a of x, times its depth. So this is all I need. Just tell me the area of the face. And we got this thing. And the area of the face isn't so crazy after all. So let's go in here with a little red. I'm laying it across this curve up above. All I need to know is how tall it is, how wide the span is from curve to curve. I just have to subtract them. My upper function, isn't it x plus 1? Minus my lower function, x squared minus 1. Bingo! That's the width of this square laid across that shaded pink region up there. And it's square, so what that means is you can take that and just write it as your height because you know that it's a square. The width and the height are the same. So over here, we've got x plus 1 minus x squared minus 1. Bingo. That's the area of the face, length times width. Just put it with a dx and you're done. So are you ready for this? This is the big home run. Here goes, equals the x plus 1 minus x squared minus 1 thingy. I'm going to square it because it's just side times side. This is my a of x right here, my face area. Face area. Face area. That sounds fun.
Or something. Can't steal your pencil.
Here we go. Got it. I got it. The rest is all beard. Glasses. Done. So that's the square one.